All right, boys and girls, welcome back to the drive-through, special three-dimensional version of the drive-through today. Hungry? Stop by the deli. Get yourself a homemade three-way from Mr. Tilton. It's delicious. All right, welcome to 6-1. We are going to start talking about planes today. We've already talked about planes, so this isn't a start, but this is a complete focus on planes in this section. And recall that a plane, according to the book, is a surface, so there's our predicate nominative, a surface such that if any 2 points on the surface are connected by a line, all points on the line are also on the surface. So, let's draw out. Often we will use like a parallelogram to define a plane. The reason we do this is because when we start to talk three dimensions, our shapes start to get morphed a little bit, you know? So you can picture that the room that you are currently sitting in is bounded by 6 planes: the ceiling, the floor, the front wall, the back wall, and the left wall and the right wall. Okay, let's talk about the ceiling plane. Okay? A plane is a surface so that if any 2 points on the surface are connected by a line, okay, that all points on the line lie on that surface. Well, it's important you remember that lines go on forever, so you might be thinking, oh, the ceiling is not a plane. Well, the ceiling is a plane segment, okay, because this plane goes on forever in every direction, and there are more than just 4 directions, just so you know. There are infinitely many directions. So, what about a surface that's not a plane? Well, let's see what I can do here. Let's say we've got something that looks like that. Okay, so, oh boy, this is going to be tough. Okay, that's not bad. Oh dear, let me start over. That screwed it up. Let me just start with this. Do this. I'm trying to draw you a ribbon, but man, I'm just not able to draw that very well. Let's do something more simple of a surface. Let's just try that. Let's draw like a half pipe. So here, you'd see the back part. That would kind of go like this. And this. Okay, that's a little better. Okay, imagine this surface here. It'd be a little better if I could shade it, but I got to make sure these look parallel. Okay. Imagine like a half pipe. Oh, jeez, I'm just failing at this. All right, well, anyway, imagine on this half pipe we have a point here and a point here. So if we have a line going through those points, those are the only 2 points that are on that surface, if you can envision the surface the way I want you to envision. And that would be an example of a surface that is not a plane, okay? Don't worry about this. That is called a failure, and it happens to all of us. So we'll move on. Sometimes you got to move on. Okay, so we have 4 ways to determine a plane. What does that mean, determine a plane? Well, you've been saying for a month at least that 2 points determine two points determine a line. Well, that means if I have any 2 points, remember I made you put your fists up in class, and I said, could I draw a line between those 2 fists? And every 2 fists on Earth we could connect with a line and make a line out of it. So we only had one way to determine a line, and now we will have 4 different ways to determine a plane. 4 different ways. Okay? So, what on earth are they talking about? Well, that means if we had 3 non-collinear points, 1, 2, and 3. These 3 points are clearly non-collinear. We could form a flat surface out of those points that would represent a plane. Now, those surfaces go on forever in every direction. So this triangle that you see is just a part or a portion of the plane. And I could draw maybe a triangular prism out of that, and you could see that those 3 points did determine a plane. Now, how many of you have ever gone out to eat and had your table at dinner be wobbly? Has that ever happened to you guys? Okay, probably. Okay, and it's quite annoying. But there is a trick that many restaurant patrons know. What if my table is wobbly at dinner? What can I do? Well, I can steal like a coaster or some Sweet and Low packets, and I can go jam them down underneath the highest foot, and now my table will stop wobbling. Well, what I want you to realize is the reason the table wobbled was because 3 points determine a plane. And so what was happening in your instance was that these 3 points, these were the longest legs, so this blue plane was defined by those 3 points. However, this leg was too short. So when Mr. Yulin sat down and put his big belly and it would bump, like rest on the table, then the table would tilt in this direction. And now it would rest on this foot, and this foot. Well, now that is a different plane formed between those 3 points. So the table was wobbling back and forth from the red plane to the blue plane, from the red plane to the blue plane. So what did the smarty pants do? They said, oh, let's make sure all these points are coplanar. Okay, let's make sure all these points are coplanar, and let's put something underneath there so that now this foot is indeed in the same plane with the other ones, and now that table won't wobble. That's how that works, okay? So, one way to determine a plane is with 3 points. Another way you can think of this is, how could you hold up a table? Could you hold up a table with 3 sticks? Yes, you could. So long as that the sticks were strongly established into the ground, that table would balance no matter where you put the 3 sticks. Assuming the table has got a relatively fair weight. I shouldn't say wherever you put it, because I guess balance and determination are different. But we could conceivably hold this table up with 3 points, because those 3 points create a flat surface. Okay? All right, what's another way to determine a plane? Well, intersecting lines determine a plane. So, you can think about it like maybe like this. You could build a table. You could put a 2x4 there, a 2x4 there, and you could hold these 2x4s up like something like this, and have them intersect like that. And you can have a cool little table that way, and you'll learn a little later, but of course those planes would intersect each other. That would be a pretty groovy table. So, 2 intersecting lines determine a plane. Okay? Well, another cool way to maybe have a similar design for your table would be to have 2 parallel lines. So, in that case, your table would look something like this. You can imagine, I guess, if I could give you a different view, it would look like that. Like that. That's what your table would look like. Okay, you can hold it up with 2 parallel lines. Okay, and then finally, the 4th way to determine a plane is a point and a line not on that plane. So if we had a similar table and we had a line holding it up, if we also just had a point being held up by a stick, okay, that table would be in place, because once again you've got a flat surface is defined by a line and a point. Okay, so basically anything that makes a triangle or a combination of triangles, triangle, okay, combination of triangles here, combination of triangles here, and we got our triangle here. Anything that makes a triangle defines a plane. Okay? Now, there's a spot where you can get tricked. So, two lines determine a plane. Always, sometimes, never. It seems like it's always, but they do not. If the lines are skew, so for instance, this line and this line, those two lines do not determine a plane because they are not parallel and they do not intersect. Okay, so there is not a single plane that goes through this blue line that also goes through the red line. Continue. Last slide. If a line intersects a plane not containing it, then the intersection is at exactly one point. Think of this like a bullet, okay? If you've got a bullet traveling down and it doesn't get stuck in the floor, then it's only going to hit the wall or the floor at exactly one point, okay? The alternative would be if the line contains the plane, then that bullet is going to get lodged into the floor and it's going to contain that bullet hole at infinitely many points, if that makes sense. Okay? And then the second postulate would say if two planes intersect, then their intersection is a line. So let's imagine that this plane, defined by this triangle here, okay, intersects another plane defined by a triangle. Like that. Well, their intersection would be that. But remember, planes go on forever in every direction. And so therefore so does the line. So it's not just a segment, it's a line. You often see this in your room that you're currently sitting at. Look at the intersection between the ceiling plane and the floor plane. You should see, a ceiling plane and the front wall plane. The ceiling plane and the front wall plane intersect at that line right there. Okay? Hopefully you guys enjoyed this plain, boring lesson. Boom!